All right, good afternoon, everyone, and welcome to our showcase presentation. We will be showing off our project, Gaze Dimension. So, to give a little bit of insight into the company that we were working with, our project was developed in collaboration with the Software Engineering Research and Empirical Studies Lab. They specialize primarily in eye-tracking studies. They are also the developers of the eye-trace framework to conduct eye-tracking studies with various developer environments. I will pass it off to Connor to talk about our stakeholders.
Great. Thank you. So a little bit on our team that we worked with on this project. Our primary sponsor was School of Computing Associate Professor Bonita Sharif, and we were also working with graduate research assistant working in her lab, Kong-Il Park. Next up, moving into our senior design team, we had our project manager was Melanie Kugler-Wright. Our tribe lead was also Dr. Sharif, and our industry coach was Hunter Dorhout. And we'll move back to Christian to introduce a bit of the team itself.
Thank you, Connor. So sort of jumping around a bit here on the team. I'm Christian. I was our multi-team squad lead. Our product managers, we have Connor and Zach. Going to our development managers, we have Eli and Gray over on that side. And then for our developers, we have Isaac, Jackson, Shane, Leo, and Waju. Pass it off to Zach.
Thank you. So the problem identified is that high school coaches and college coaches spend a lot of time reviewing film, both alone and with their athletes, and being able to critically watch and analyze that film is a skill that's key to an athlete's development, but it's hard to teach. There's currently not a precise way of knowing where coaches or athletes are looking at while they're looking at film, at least not one that's super accessible. There's often a disconnect in what they think they're looking at and what they actually were looking at. A coach or an athlete may wrongly report that what they were looking at based on what they think they should be looking at. So this makes training and evaluating viewing behavior on sports video pretty difficult. Eye tracking is often hardware dependent and it's not tailored for the use case of sports video. So our team was tasked with creating a web-based application that uses eye tracking to aid in coaching and instruction. To keep this solution accessible, scalable, and convenient, our solution uses a webcam as opposed to conventional hardware-based eye tracking to accomplish this. We can't expect a sports team, especially at the high school level, to invest hundreds or thousands of dollars into eye tracking equipment, especially when the equipment they currently use for coaching is mobile devices like iPads. So making eye tracking mobile is a key part of the problem that we are trying to solve. To tailor this towards laptops, tablets, phones, mobile devices, etc., accessibility and ease of use were prioritized in the calibration of the eye tracking process. Instructions are straightforward. You can gather information about the user's screen size using a credit card. A simple process can determine the user's distance from the screen. Eye tracking calibration does not require the user to click or touch anything. It's all hands-free to make it super accessible. They only need to follow a dot as it moves around the screen and collects data to more accurately predict what they were looking at. This includes dynamic calibration, where the user guides the calibration by looking at one of the points, as you see there in the middle, ensuring that the initial calibration was accurate. So I'll pass it off to Connor to keep talking about our solution.
Great. Thanks, Zach. So this is the first page that users are presented when they log into our web application. A key part of this project for us was making sure that we had a nice cohesive design across all the different parts of our project, and we really wanted to make design a big part of it. So they're greeted with this simple page at the beginning, giving them a quick description of what our product does, as well as links to our documentation. They also have the option to sign in or sign up for their accounts from this page. Next, this is our member manager. This is where coaches can go to manage the members on their team, both the members that they've already invited and ones who they're going to send invites to and haven't accepted yet. We originally had these separate between invitations and members, but through our review process and working on this project, we found a combined cohesive view was best for us and what we thought that coaches would like to have. Add button is right up there. That's where the coach would be able to go, enter in the information they need for the athlete that they want on their team, and that'll get them added to the team. Future work for this could include getting emails set up so that it sends an automatic email invite to the student. Also listed on here are some of the technologies that we used. We used React and Node.js to build the front end. We also used Material UI, which is a design framework for React to kind of help keep everything cohesive. And we used Django as our backend solution in Python. Finally, this is our assignments page. This is the coach view, where a coach could create an assignment for the athletes on their team to go watch film and collect eye tracking data. From here, the coach can add assignments, delete these assignments, and also define different data points that they want to make sure athletes are paying attention to. We'll go over a little bit of that in the next couple of slides. But this is a simple, easy, cohesive view for the coaches. Athletes have a very similar view that shows them what they need to do, when it needs to be done by, any sort of comments, and allows them to access the eye tracking implementation. And speaking of that, I'll pass it to Christian to talk a little bit more about that.
Thank you, Connor. So taking a look here at our AOI creation and post-processing. On the left, you can see sort of how a coach will designate an area of interest. They are able to draw polygons on the screen, and then they use the bar at the bottom to designate the time frame that it is active for. And these areas are sort of how the coaches mark where they think the athlete should be looking during the video. These areas of interest are also used by the post-processing to help inform some of the metrics that we give on the reports page. On the right here, you can see our heat map. That is an aspect of our reports page. So when the coach is looking at the report after an athlete has completed the assignment, they can either look at the heat map or the gaze plot of the different points that they were looking at. And then with that, we also display some metrics such as time spent looking at areas of interest and also the number of fixations. Moving on to our highlights. Just a couple of things here. For me in particular, as a second-year senior design student, it was a really unique opportunity getting to work on a multi-team project. Having the expanded number of team members, being able to work on a larger project and being able to split that up more to the point where team members could really specialize in different subject areas, and then being able to incorporate that all into the larger project. Great example of that was the end of the first semester when we had the web app team and the post-processing team bringing those pieces together into a unified web app. And then with working with eye tracking, that was really a novel experience for most of us. Sort of in that area of study, not none of us having experience, we really dug in, got engrossed in the different aspects of eye tracking, and I think that we all gained a lot from this project. Moving on. Thank you all for attending our Senior Design Showcase presentation. Make sure to come by our booth and check out our demo. If time is permitting, we can answer any questions.